Now I'd like to talk to you guys about best practices because we've done most of the work so far, but whenever you're defining these kind of things, there are some best practices to keep in mind that will save you from trouble. So let me tell you what that is. First of all, we need to normalize all these vectors. If I go ahead and press D for display, let's bring back our markers, and these markers are going way too far. I mean, you can see, especially in the Y, look how crazy that is. So we want to fit these values between 0 and 1. It's very easy to do that in Vex. All you need to say is normalize, and then capture whatever you like to normalize within parentheses. This will work on vectors, like that. And last but not least, let's do it up here as well. There we go. And the submarines turn gray like this because that's just a little graphic bug. Oh, see, yeah. Lucky for me, I saved right before that happened, so we're good. Okay, as I was mentioning, we have normalized vectors. That's great because if we ever decide to turn this into a quaternion, the quaternion wants normalized vectors. It really kind of freaks out if something is not between 0 and 1. So because of that, you always want to normalize your vectors. Now, if I go to copy to points, our submarines are still facing the wrong way. Let's hope that doesn't crash. Okay, we're good. And that's because this y-axis right here is something that the copy to points does not understand. It will, however, understand up. There we go. Now we have our subs facing upwards in the correct direction. I'm also going to turn off these visualizers just because I think that's causing the viewport to freak out a little bit. So there we go. Hopefully that doesn't keep on happening. Anyway, we now have up, and there's one more thing that we ought to do to check and make sure that this is all proper. And that is we want to look at the determinant value. What does that mean? Well, just know this. If we create a determinant value, which is a float, so f at determinant val, and we set it equal to this determinant function. Let's press F1 and see what we need. So we are going to need to feed this a matrix of some kind. And what we want is that this determinant value, this determinant function, will basically tell us if we have a proper rotation. If the value is 1, we're good to go. That means we have a clean rotation and everything is working as it should. Anything that's not 1 typically means that something is off. And in this case, it's very easy to tell if the submarine's facing the wrong way or if it's not really rotating the way it should. However, this becomes much less obvious whenever you have certain sort of destruction scenes where maybe, let's say, you had a giant boulder explode and you just see a bunch of rock pieces. And it's not really obvious which way the rock should be rotating or that sort of thing. This determinant value will help you determine if your rotations are clean. That's how I think of it. Also, if your vectors are not normalized, then it will give you a value that's not 1 typically. And that'll tell you that you need to fix that. As I was mentioning, this determinant value needs some kind of matrix. So let's create a rotational matrix based on the vectors that we have. To do this, let's say 3 at, and let's call this matrix our deter m for right now. If I use the set right here, I can now specify x, y, z. So our x in this case is our x axis, z is our normal, and y is up. Lastly, for this determinant, let's feed this the matrix now, deter m, and I need an @ sign right there, and an @ sign right there, and now let's see what we have. Let's hide all of our attributes, and now just isolate the determinant val. So right now we have a determinant value of 1, which is good. Obviously, it's not facing the correct direction, but that tells us that we have normalized vectors that, in general, this shouldn't freak out if you ever send it to a quaternion of some kind. All we need to do now is just turn this around. So let's take our z-axis and make it negative. Boom. There we go. In the next lesson, let's turn this into a quaternion-based rotation and also look at how to blend rotations.